All right, here's our homework 2 video. We're finding locations of horizontal and vertical tangents for these implicit curves. Remember when our derivative is equal to 0. So if a numerator equals 0, I'll have a horizontal tangent. Vertical tangents, when a derivative is undefined, or when there's a 0 in the denominator. We're going to go through the process of taking the derivative, finding dy dx, and then setting up equations to solve. So let's go ahead and take the derivative. Remembering our derivative rules for y's. I'm going to quickly do this because we should have done this enough. We should know why this is the correct derivative. I subtracted 2x, added 6, factored out the dy dx. Maybe for the first one I'll show, but then for future ones I won't. So subtract the 2x, add the 6. Factor out the dy dx. Divide to solve. Okay, horizontal tangents. The numerator will equal 0. I'll get x is equal to 3. Vertical tangents. The denominator will equal 0. I'll get y is equal to 2. As for the xy locations, so just practicing taking this x, plugging it back in, taking this y, plugging it back in. I get 9 minus 18 plus y squared minus 4y equals negative 9. That's negative 9 plus y squared minus 4y equals negative 9. So that's just going to be y squared minus 4y equals 0. Factor out a y. I'll get y is 0 and 4. So that's 3, 0. And 3, 4. Vertical tangents, plug in the y. And I get x squared minus 6x plus 4 minus 8 equals negative 9. X squared minus 6x. That's going to be negative 4. I'm going to add the 9 to the negative 4 to get 5. Yep. Factor that. X minus 5, x minus 1. And I get x equals 5 and 1. So 5, 2, 1, 2. Let's do the same for this one. Two y minus 2y dy dx minus 2 dy dx minus 4x cubed plus 32 equals, don't forget the derivative of the right side is 0. Solving for dy dx after adding, factoring, and then dividing, I'd get positive 4x cubed plus 32 over 2y minus 2. Horizontal tangents will be when the numerator equals 0. And subtract 32 divided by 4. 32 divided by 4 is 8. Cubed root of 8, 2. That's nice. Okay. A little bit easier. 2y minus 2 equals 0. Add 2, y is equal to 1. Let's find the other half. Let's see if we can. Sometimes we won't be able to. So sometimes we'll just stop here at the x and the y coordinates. But I asked you for the xy location, so let's go for it. This is y squared minus 2y minus 16 plus 64 equals 96. Let's see, minus 16 plus 64 minus 96 is a negative 48. So y squared minus 2y minus 48 equals 0. 8 and 6, right? Y minus 8, y plus 6. Add to get negative 2, multiply to get 48. So y is equal to 8 and negative 6. So I have 2, 8, and 2, negative 6. Here I have 1 minus 2 minus x to the fourth plus 32. X equals 96. I don't like the minus x to the fourth, but I'll worry about it in a second. 1 minus 2 minus 96, negative 97. Maybe let's flip it and factor out a negative 1. I don't have to, I mean, yeah, I should just leave it out there. Are there two numbers that add to get negative 32 and multiply to get positive 97? Work. 97 doesn't really have any factors. Is 97 prime? If 97 is prime, we're done here. Yeah, 97 is prime. So, I can't solve this, so I can't find the x-coordinates without a calculator. Don't worry about it. Let's check out this one. Next to 2x plus 2 minus 2y dy dx equals 0. Okay, dy dx equals negative 2x minus 2 over negative 2y. Okay, no big deal. Horizontal tangent, negative 2x minus 2 equals 0. X will equal negative 1. Vertical tangent, 2y equals 0. Y will equal 0. So again, let's find the points. 1 minus 2 minus y squared equals 3. That's negative 1. I wonder what's going on here. I think that we have a situation where we're not going to be able to see this point. So I don't want to worry about square roots of negatives, so we'll look at the graph. Let's see a vertical tangent at y equals 0, x squared plus 2x equals 3, x squared plus 2x minus 3 equals 0, x plus 3, x minus 1. That works out. So negative 3, 0, and 1, 0. Take 32. Yep. Mm-hmm. Let's see, what is the graph of x squared plus 2x minus y squared equals 3? I can see it's got vertical tangents, and it probably doesn't have a horizontal tangent. So you can see when x is negative 1, we don't have any graphs. So are you going to have to kind of know that? No, I'm going to give you problems only where it's set up for you to succeed. But notice vertical tangents, negative 3, 0, 1, 0, 1, 0, negative 3, 0. Okay. For this one, (2x plus 3y squared dy dx minus 3 dy dx equals 0. Subtract 2x, factor out the dy dx, you get negative 2x over 3y squared minus 3. Let's see, horizontal tangents, negative 2x equals 0, x is 0. Vertical tangents, 3y squared minus 3 equals 0. Add 3 divided by 3, y squared is equal to 1. Y will equal plus or minus 1. Okay, so if x is 0, get y cubed minus 3y equals 4. You know, you guys can't solve this. I can't solve this, so let's just stop there. Let's see if I can find the x coordinates. I'm going to go back and say, if you can. All right, if y is 1, x squared plus 1 minus 3y equals 4. No, it's minus 3. X squared plus 1 minus 3 equals 4. X squared minus 2 equals 4. X squared equals 6. X equals plus or minus root 6. Okay. If y is negative 1. X squared minus 1 plus 3 equals 4. X squared equals 2. X equals plus or minus root 2. Got a lot of points. We got like 4 potentially. We're going to have to look at this graph because if this is correct, that's impressive. We got root 2, negative 1, negative root 2, 1. X squared plus y cubed minus 3y equals 4. What? Look at that. 1, 2, 3, 4 locations of vertical tangents. One location of a horizontal tangent when x is 0. We couldn't find the y coordinate. That's fine. But we found when x is, when y ends up being negative 1 right here, and then y is positive 1, you got vertical tangents. Cool. Here, find the x or y coordinates of the horizontal and vertical tangents 4. So this is great. So we won't have to do the extra step of finding the x comma y. We can just stop. All right, I got 2x. All right, minus. I like to bake in the negative. I'm taking the derivative. So this is negative 3y plus dy dx times negative 3x. That's what I like to do. Plus 2y dy dx equals 0. I'll solve for dy dx. Get negative 2x plus 3y over negative 3x plus 2y. All right, we got issues. Horizontal tangents. I get negative 2x plus 3y equals 0. I don't have a quick x or y equals 0. I'm going to have to, same with the vertical tangents, solve for a variable. And I'm going to plug into the original equation, which will create a system. So I'm probably going to solve for y here. Y is equal to 2/3 x. And let's take that and substitute it in. So whenever I see y, I'm going to replace it with 2/3 x. So I got x squared minus 3x 2/3 x plus y squared equals negative 5. Get x squared minus 2x squared plus, whoops, y is 2/3 x. Plus 4/9 x squared equals negative 5. All right, let's see how that works out. Negative x squared is negative 9 over 9x squared. So that's negative 5/9 x squared. Oh, this works out phenomenally. I'll get x squared is equal to, multiply by 9, divide by negative 5, I get 9. X is equal to plus or minus 3. All right, vertical tangents. Let's see. I'm going to solve for y as well. It ends up being y is 3/2 x for vertical tangent. Don't have to solve for y. Sometimes it's easier to solve for x. Let's just see. I'll get x squared plus negative 3x times 3/2 x plus 3/2 x squared equals negative 5. This becomes x squared minus 9/2 x squared plus 9/4 x squared equals negative 5. I don't know if this is going to work out as nice. Let's see. Let's just change it to fourths. 4/4, negative 18/4. 9/4. That's negative 9. 8, 7, 6, 5. Yep. Negative 5/4 x squared. We'll get x squared is equal to 4. X will equal plus or minus 2. All right, so for this curve, we have horizontal tangents at like negative 3 and 3. We'll have vertical tangents at negative 2 and 2. X squared minus 3xy plus y squared equals negative. Okay. Horizontal, negative 3, 3. Vertical, y equals, no, x equals negative 2, vertical, 2, vertical. Okay. We won't have to do any extra work there. Let's try this one. Because you're just finding the x or y's, so whatever works out easily is to find. So I got 3y squared dy dx. Make sure we use the product rule. Bake in the negative if you want to. Plus negative 1y plus dy dx times negative x. Product rule, I put a 1 here. I change this to negative 1x times y. Solving for dy dx, I'm going to get y over 3y squared minus x. Horizontal tangents, easy. Y is 0. Done. Vertical tangents, I get 3y squared minus x equals 0. In this situation, it is not easy to solve for y. I'm going to have a plus or minus root. I don't want that. So solve for x. X equals 3y squared. I added x to both sides. Now, notice, solving for x, I need to substitute in x into my original equation, not for y. So I got y cubed minus 3y squared is x times y equals 2. Y cubed minus 3y cubed equals 2 minus 2y cubed equals 2. Y cubed equals negative 1. Y equals negative 1. Fantastic. Remember, if you wanted to find the other halves, it's easy. You plug in the plus or minus 3 in this equation, not the original equation. So it's like 2/3 x. If I plugged in 3 into 2/3 x, I'd get positive 2. If I plugged in negative 3, I'd get negative 2. If I plugged in 2, I'd get 3. If I plugged in negative 2, I'd get negative 3. Okay? So it's actually not hard to find that other half. Same here. To find y, the x, it'd be 3. Sorry, negative 1, yeah. Okay, so just remember that. All right, second derivatives. Here we go. We got to find the first derivative. Take the derivative. Solve for dy dx. You get negative 2x over 2y. I can cancel the 2's. Be ready to take the derivative again. I get d squared y over dx squared equals the derivative of the first times the second minus the derivative of the second times the first, all over the bottom squared. You should be comfortable taking what dy dx is equal to and substituting it in there. You will be asked on tests to do this type of substitution to show a second derivative equal to something in terms of x and y. But if you want to find the second derivative at a point, you do not have to worry about simplifying this more. So I'm not going to. I got negative 1 minus negative 3 times negative 3 over 1. So that's negative 1 minus positive 9, which is negative 10. So it tells me the function is concave down at that point. That's not a function, but x squared plus y squared, which is a circle, equals 10, is concave down at 3, 1, because d squared y over dx squared is negative. Okay, let's do this. Second derivative. 3y squared dy dx minus xy plus dy dx times negative x. Just did this derivative. Make sure you, distribute the negative. Equals 0. Make sure you use the product rule. So dy dx equals y over 3y squared minus x. We just did that. Second derivative. D squared y over dx squared equals derivative of the top times the bottom minus the derivative of the bottom, use parentheses, derivative of the bottom times the top, over the bottom squared. Okay, now, knowing that you can plug this in there, you could. But I'm not going to, just for messiness sake. Instead, what I'm going to do is start evaluating. And the first thing I'm going to evaluate is what is dy dx at negative 1, 1? If I plugged in negative 1, 1 into this, I'd get 1 over 3 minus negative 1, which is 1/4. Okay, so that's going to be used, this 1/4. So if I was going to evaluate, oops, this is dy dx. If I was going to evaluate d squared y or dx squared at negative 1, 1, I would have 1/4 every time I had dy dx. 3 minus negative 1 is 4. 6 times negative 1 times 1/4 minus 1 over 1 over, it's going to be 4 squared, 16. Okay. So let's do some work here. We got 1/4 times 4 is 1 minus negative 6/4, which is negative 3/2 minus 1 over 16. Gosh. Which is minus 5/2. Seven halves over 16, 7 over 32. That's our final answer. Okay. I hope I did my calculations correct. I might not have. Given a derivative, find the second derivative. So this is nice. Sometimes you will be given dy dx. So you need to remember that you'll have to use dy dx, but I don't have to take the derivative twice. I'll use the product rule, derivative of the first times the second, plus derivative of the second times the first, at the point 1, 2. Now, if you wanted to, you could go ahead and plug in what dy dx is equal to, this y squared times 4 minus x squared. Or you could just have evaluated dy dx at 1, 2. Be ready to write it in this form, in terms of x and y form, but this is fine. So this is 2y times dy dx times x squared plus negative 2xy squared. And let's evaluate this at 1, 2. I get 4 times 4 times 3 times 3 plus negative 2 times 1 times 4. So 9 times 16 is 144 plus negative 8, 136. Okay. Given dy dx, find the second derivative, determine the concavity for all points in quadrant 2. Okay, well, let's just start by finding the second derivative, d squared y over dx squared. I get 2 minus dy dx. All right, well, to really kind of understand what's going to be going on, why don't we find that in terms of x and y. So it's 2 minus dy dx is 2x minus y, so minus 2x minus y. So that's going to be 2 minus 2x plus y. Okay. In quadrant 2, let's think about quadrant 2. The x's are negative, the y's are positive. If the x's are negative and the y's are positive, my second derivative will be 2 plus a positive plus a positive. And the second is the positive because it's negative 2 times a negative. So it's like, let's think about that. 2 negative plus a positive. So that'd be 2 plus a positive plus a positive. That means the second derivative is always going to be positive. So that means second derivative is positive and concavity of the points is up. The second derivative test allows you to find a max or min by examining the concavity of your curve at the location of a horizontal tangent. -1, -1 is a horizontal tangent on the original curve. By examining the concavity of the curve, tell me if -1, -1 is a max or min. Okay, so we're given some curve, and we're told that -1, -1 is going to be a horizontal tangent. Okay, and I can see if I plugged in -1, -1, I'd get 0. So yeah, horizontal tangent. Now watch this. If I take the derivative of this to get d squared y over dx squared, I get 2x plus dy dx. And if I evaluated that, d squared y over dx squared at -1, -1, I would get 2 times -1 plus, if I plugged in -1, -1 into the dy dx, this is a 0. So I get -2. So that means the curve is concave down. Now let's think. If I know something is concave down but has a horizontal tangent, here's something that's concave down and has a horizontal tangent. Is that a max or a min? It's a max. We just used concavity to determine maxes or mins. The second derivative test, we didn't really do this much back in Unit 3 because we didn't have to. We were able to usually examine signs of the first derivative, but that's actually kind of tough when we have x's and y's. So the second derivative test is helpful. All right, switching gears, we are introducing related rates. We're going to be taking derivatives with respect to t. We're going to see how quantities change at a specific moment in time. No longer is the derivative of x squared just going to be 2x. It's going to be 2x dx dt. Just like the derivative of the y's always had a dy dx after, the derivative of anything besides a t will have a d blank dt afterwards. What's great is that we're not going to have to solve for anything. We're just going to leave it like that. This is 2x dx dt plus 2y dy dt equals 2d dd dt. Ooh, I thought that was it. I write it a little smaller. 2x dx dt plus 2y dy dt equals 2d dd dt. And we're taking the derivative with respect to t. Product rules. Derivative of the first would be 4 dx dt. Y plus dy dt times 4x minus dr dt equals 0. Everything still applies. Given the information and your derivative from above, find dx dt when dy dt is -3 when x is 3. So it's like if x is 3, what is dx dt when dy dt is -3? It's like, oh, well, I don't know. Like, I don't know what y is. But I can find what y is. If you look at this equation, I think I should be saying assume x, y, z, r are all positive. Okay, so let's just assume that. But what is y? I could find y in my original equation when x is 3. So 9 plus y squared equals 10. Y squared equals 1. Wait. Yeah. Y is equal to plus or minus 1. We're going to assume we're just talking about positives. So when y is 1, now I get 6 dy dt, sorry, dx dt plus 2 times 1 times -3 equals 0. 6 dx dt plus -6 equals 0. Add 6, divide by 6, I get dx dt is 1. Okay, find dd dt, and dx dt is 2, x is 4, d is 5. So we got 2, 4, dx dt, 2. I got 2, don't know what y is, dy dt is 3. I got 2, I forgot about this. You could divide everything by 2 here. Makes it a lot nicer. Like, get rid of that 2. Get rid of that 2. 2 times d is 5, times dt. Okay? Well, again, I have some missing information. I don't know what y is. So it's not always going to be y that's missing. I do know x is 4, d is 5, and that x squared plus y squared equals d squared. I'll get y squared is equal to 9. Y is plus or minus 3. We'll just say y is 3. So 8 plus 9 equals 5. 17 over 5 is d dt. Find dr dt, given x equals y equals r, which is 1. Dx dt is 2, dy dt is 3. So dx dt y 4 plus dy dt x minus dr dt equals 0. 8 plus 12 is 20. Dr dt will equal 20. All right, a lot of work there. Pay attention to details. I was a little messy. Try not to be messy, or just keep track of it. And come in with any questions if you have any. Thank you.